So anything you get will have the separated, what they did before, so what they did before, the way they had it before was actually on our Gen 2 product. When they came out with Gen 3, that's when they decided, okay, we're gonna take the S1, S2 off of the 24-volt terminal board and we're gonna make it its own, connection. So anything you all get will have the separated connections. When do you want to take a break, Aaron? I mean, I can keep going, it's not a big deal, but I just want to make sure that I usually go about an hour and a half or so.
Yeah, that's fine.
Yeah.
Let's go about 20-ish more minutes and then let's give everybody a 10-minute break.
Okay. All right, so automatic airflow adjustment. Now, we have the ability, or you have the ability now to be able to change your heating and cooling airflow for the heat pump. It has to be done through engineering mode. You shouldn't have to mess with it except in certain cases. It's not something you're gonna do every time you install one. All you have to do is it's gonna go case by case. It's channel 23 and channel 25 in engineering mode. You can increase or lower the CFM for your heating and cooling on the heat pump. Well, auxiliary heat's controlled differently. All right, auto discovery. Meaning, if you use a 24-volt thermostat or you use the wired wall control, the system will auto discover or auto detect what control method you're using. On the wired wall control, as soon as it powers up, first thing it'll do is try to start communicating with the AHU. When it starts communicating with the AHU detects it and then puts it in full communication mode. If you use a 24-volt thermostat, first time you send a Y signal or first time you try to turn the system on, it'll see the 24-volt input on it without the HAHB, and it will put it in 24-volt mode. If, however, it doesn't pick up some thermostats, now there are some thermostats that it may not pick up. If it does not pick up your 24-volt thermostat, flip SW1-1 on, and that puts the air handler in 24-volt mode. All right, those top two scenarios are the two we're going to focus on. This one down here, these down here, just forget they exist because we're not going to talk about them. That is emergency only. So scenario 2, which is HAHB full communicating with S1, S2. Here's how it wires up. HA to HB, S1 to S1, S2 to S2. The SW1-4 puts the air handler in standalone mode. Now, you'll notice here that it's flipped on. Now, in our manuals, dip switch positions, the black always indicates the switch position, not the white. You notice SW4 is flipped on. If for some, you shouldn't have to do that. But if for some reason it does not pick up or detect the wired wall control, flip that switch on and it forces it to start looking for it. You shouldn't ever have to do that though. I've never had a problem with a wired wall control not picking up.
Like you said, the only time we should have to do that is if we're already having and communicating, we've got to throw a wired thermostat on there in an emergency situation.
Exactly, that's it. If you, no, so in an emergency, guys, one thing, in an emergency, guys, if you have to take it off the communication wire and you have to put it on full 24-volt control, to try to get Bob and Mary's heating and air conditioning to come on. So remember I told you dip switch SW1-2 on the outdoor unit has to be flipped on to put the outdoor unit in 24-volt mode. SW1-1 and SW1-4, you need to flip those two on. That puts the air handler itself in standalone mode and 24-volt mode. Flip those two dip switches on, flip SW1-2 on the outdoor unit on, and then you have full 24-volt control for your emergency use.
So realistically, if a dealer showed up and they forgot the thermostat and they're miles from the branch, they could set it up in 24-volt mode, but then when they go back with the thermostat,
They have to flip the dip
that's
switches
when they
back
would
on.
have to go through that protocol.
Right.
But even still, and if we've got to change the thermostat in an emergency situation,
Right.
we don't have to put the air handler in 24-volt mode, we can leave it in full communication with the outdoor. So 24-volt
Yes,
staff.
yes, if you're using full communication and it's just a wired wall control, you can just put the air handler in 24-volt mode and not have to worry about this.
Because it's already gonna communicate, and we wanna prefer that communication wiring on every install, and it will already be that.
Right.
Yeah.
Now, sometimes I know if for some reason there's a communication breakdown between the indoor and the outdoor, and you can't get it to communicate on S1, S2, then you can put it in full 24-volt control.
Eric, we had a question earlier, when it coming through operation, we were looking at the D terminal on the outdoor unit in 24-volt mode. Since we're recommending S1, S2 from indoor to outdoor,
Right.
during a defrost cycle,
Mm-hmm.
and there's communication from our indoor to outdoor, the outdoor unit communicates to the indoor unit, it's going through defrost.
Mm-hmm.
What does the indoor unit do when the outdoor unit goes into defrost?
Shuts the blower off.
Shuts the blower off and does not engage strip heat.
Oh.
And strip heat is only engaged when the thermostat calls for strip heat.
Correct.
Hope everybody heard that.
Yeah, so in communication mode, whether you're using 24-volt thermostat or whether you're using the wired wall control, if you're doing S1, S2 to the outdoor, when the unit outside goes into defrost, the anti-cold air function of the air handler shuts the blower down during defrost. We do not energize auxiliary heat.
What is the maximum amount of time that outdoor unit could be in a defrost situation? Worst
I
case.
believe it's 15 minutes.
But in
the
standard
max.
time, in standard defrost cycles, we're
In
talking.
standard defrost cycles, you're looking at 5 to 6 minutes.
So we're talking 5 to 6 minutes of no blower, no heat, we're not cooling,
Right.
not a big deal.
Right. Yeah, typical defrost times are about 5 to 6 minutes.
If we're already running auxiliary heat
Mm-hmm.
and we get a call for defrost,
Mm-hmm.
blower stays on, auxiliary heat continues, unit goes for defrost, or do we shut it down?
You're gonna have to let me ask about that, because I've not run into that scenario. I've not run into that scenario on communication. But I will ask about that.
In full 24-volt mode, we can tie the D terminal to W1 on the inside and it'll bring on.
It'll bring on the auxiliary heat, yes. Yeah, if you ever have an instance where you have to use full 24-volt mode. Okay. Yeah, the D terminal is used for defrost. All right. You just have to let me ask about that one. I'm not sure how that operates and I don't want to tell you wrong.
Well, I mean, and we're gonna be suggesting that thermostat be used,
Right.
and that thermostat's gonna be communicating, and so the system will know.
Personally, I would assume the way ours works, especially if you're full communicating, personally, my thoughts on it would be that even if the auxiliary heat was running and the outdoor unit called for a defrost, it would shut everything, it would shut the auxiliary heat and blower off inside. Because during a normal defrost, we don't energize the auxiliary heat.
And the way I think of it is, Midea,
Uh-huh,
ductless, that's a very ductless way of doing a defrost cycle.
yes. Yeah. The algorithm and the control software that we use on this was adopted from the ductless. So there are a lot of duct features that we use on our ductless that are part of this. And to me, it's more efficient just to shut the blower down while it's in defrost for 5 or 6 minutes than it is to bring the auxiliary heat on for those 5 or 6 minutes.
Oh, absolutely, let's not run 15,000 watts for 6 minutes of a non-heating cycle.
Exactly.
Right?
Yeah. So, but I will ask on that, Aaron, and get you a for sure answer. Thank you. All right, so full communication versus 24 volt. This is even with S1, S2. Everything that's got a check mark on it, you keep with 24 volt. Everything that's got an X on it, you lose when you go from a wired controller to a 24 volt thermostat. You lose full communication with the system. You lose the 2-wire connection. You lose the Wi-Fi ready. You lose well, you actually have control from the app because most of these thermostats have an app on it. Right? 5 different fan speed settings. 5 different modes. Heat pump plus auxiliary, cooling, auxiliary only, and auto are the 5 modes that are available on the wired wall control.
Oh, wow, so we can be in a heat pump only with non-auxiliary.
Right.
So it will never kick on auxiliary.
Right. The auxiliary will never kick on if you got it in heat pump on.
I'll be careful of that with some cold climate areas. But this is such a cold running unit for cold climate heating.
If it was me, and I wouldn't care if I was in a cold climate, first thing I would do is leave it in heat pump only mode, and I would run it until it wouldn't keep up.
Yeah.
Just to see where the auxiliary heat, where I needed the auxiliary heat.
I mean, the only time that'll become a problem is if the neighbor.
But then again, you know,
the power of the outlet.
I happen to know a guy that works on heating and air conditioning too, so. But yeah, if it was me, I would test it. Okay, so, yeah, 3 different heating modes. You lose the ability to have 8 events. Now, those 8 events, guys, on our wired wall control, you have the ability not just to change the temperature based on the time, you have the ability to change the mode and the fan speed. You lose that with a 24 volt control.
So those customers that like to cool their house, their bedroom is 65 at night, and then heat the house to 70 throughout the day.
But that's also the other thing they can do too. They can also change the fan speed for that period and put it down to low so that they don't have the noise from the fan. Does that make sense?
Yeah, awesome.
You lose data checking mode from the wired wall control, but not from the unit. You still have that ability. The air code display, you lose the air code display on the wired wall control on your thermostat. And then heat pump and heat strips low temperature setting. So you still have that with most of these smart thermostats on the even on 24 volt. But that's what you lose. Those are the functions and features that you lose when you go from a wired wall or 2-wire wall control to a 24 volt thermostat. All right. Indoor and outdoor unit need power separate from the outdoor unit. Indoor and outdoor need power from outdoor unit. I have to ask Sam what he means on that, because that's a little confusing.
Indoor and outdoor, oh, the indoor unit and outdoor unit are powered separately.
As opposed to having power ran from the indoor unit to the outdoor unit, like a
Yeah.
standard ductless one.
Right,
Yeah, I think that's all he's saying,
yeah,
because most people think of a ductless product that where it's powered just from the
Outdoor unit, right.
Especially if you can run one
We
with
gotta have
door
power.
board and blower, and then 240 or strip heat, and then separate 240 for our outdoor unit.
Right. All right. Indoor unit, outdoor unit need just the 2-wire communications. Indoor and outdoor unit, indoor and Midea wire wall control, HAHB 20 volts DC. And then the retrofit, even with a retrofit, you don't, like we talked about before, you don't have to change the thermostat, the existing thermostat wire. You don't have to. If you can, you can. If you can't, you can't. Basically, is the way I want to look at it. All right, so T1, TS are communicated to the indoor unit, which T1 is your return air temperature. Basically, it's going to be the T1, it's going to be the room temperature off the ST1. T2A, T2, T2A, T2B are on the indoor unit. T3, T4, T5 on the outdoor. Suction sensor, pressure transducer, and refrigerant temperature are not used in S1, S2 communication. They're actually not used for full communication. The outdoor unit controls its EEV, compressor, fan motor, and the 4-way valve. And then the indoor unit controls its own EEV and the fan motor. All right, so let's talk about dip switches. Now, what I'm going to talk about on dip switches right here only applies to full communication. These are going to be different when we look at 24 volt, even with S1, S2. So S1-1 is your control function. All of our dip switches come, with the exception of S4, come in the off position by default. S4 is the only one that's on. S1-1 is your control function, whether it's 24 volts or whether it's wired wall control. S1-2 is your anti-cold blow or your anti-cold air function. On or off. You can flip this switch on if you have customers or a customer who likes to have the fan run all the time. Remember, in heating mode, the anti-cold air function, once the T2 temperature drops, I'm gonna tell you, once the T2 temperature drops below 77 degrees Fahrenheit, that fan's gonna shut off. So when the unit powered or the unit cycles off, once that cold temperature drops below 77, and it will eventually, that blower shuts off. And it does not reactivate again until the heat pump comes on and the coil warms up to 89 degrees. That's the anti-cold air function.
even if there's a fan set on.
Even if they've got the fan set to on, the anti-cold air stops the blower in heating. Now, it doesn't affect cooling, but it does affect it in heating. If you have a customer that wants to leave that fan run continuously, even in heating, flip SW1-2 on and it defeats the anti-cold air function. SW1-3 is your single heating or single cooling and heating and cooling option. Basically, if you had to hook this up to a cooling only or hooked it up as cooling only, you could flip that dip switch on, it turns into cooling only. I'm kind of like Stefan on that. I don't understand why anybody would buy a heat pump just to turn it into an air conditioner.
Some people just want an AC only.
Yeah, I know, and I get that. I get that. But the other thing is the only thing that comes to mind is that the cost difference is really not that great. especially on our product, the cost difference wouldn't be great enough to buy just a cooling only unit. SW1-4, like we talked about before, SW1-4 puts the air AHU in standalone mode. By standalone mode, it means it basically it would work just like any other air hammer out there.
The temp heat,
Temporary heat. Temporary heat. All right, SW2-1 is the temperature differential to activate the first stage of auxiliary heat. Out of the box, it's set for 4 degrees F. I personally don't like 4 degrees F. We have tried to get them to change it. I think that's too much of a gap.
So we're not gonna bring on auxiliary heat, if we're set for 70 degrees, we're not bringing on till house temps gets to 66.
Right.
That's probably gonna create a complaint from a lot of homeowners.
Okay, so this is why I'm telling you all this, okay? If you flip that dip switch on, it drops that to 2 degrees Fahrenheit.
That's acceptable.
Yeah. We have tried to get them to change this to 2 and this to 1.
I think there's some energy codes that'll buck you on that.
Well, probably, and that may be why we haven't been able to get it changed. We don't like a 4 degree gap. I don't like 4 degree gap.
Yeah, there's some energy codes out there that are fighting on that,
Yeah, I'm sure.
California especially.
Well, that explains that. I'm not gonna say any more. Okay, SW1-2 is electric heat on delay. That works. SW2-3 works in conjunction with SW1-2. SW1-2 is a auxiliary heat or electric heat on delay. Comes out of the box with no delay. If you turn it on, you have the option of 15 minutes or 30 minutes. If there's ever a reason or a situation where you just want to delay the auxiliary heat coming on.
Well, if you're coming back from a really far setback and it's more than 4, and definitely more than 2 degrees.
Yeah, and I'm okay on setbacks. I don't recommend more than 3 degrees anyway.
But if they did, and they
Mhm.
complained that their auxiliary heat's coming on every day for 5, 10, 15 minutes, then we could set that delay and allow the thermostat.
To delay the operation of the
Delay the
auxiliary
operation
heat
and give
and
the
force
operator
the, give the heat pump more time to actually make the temperature up.
Especially since how long does it take for that outdoor heat to get up to full capacity?
Well, it actually starts more towards full capacity.
Okay.
And we're gonna explain that a little bit later.
is there algorithms built into the system? So like, let's say I'm coming out of a setback
Uh-huh.
and that it looks and says, hey, I'm gaining at this rate.
Mhm.
I'm gonna keep auxiliary heat off and I'm just gonna keep.
Well,
driving.
remember, so here's the deal. So remember, you still have a 2 degree, so if you turn that switch on, you still have a 2 degree gap. So once you hit the 2 degree gap and you get less than, equal to or less than that 2 degree gap, the auxiliary heat shuts off. That gap is still active.
I'm just, even if it's coming out of like a setback, does it look at it that way, or does it just look at, hey, compressor heating is gaining at the right ratio, we're gonna leave strict heat off?
I don't think it does. I think once you hit the gap, that the auxiliary heat's gonna come on.
Okay,
Even in full communicating mode?
Even in full communicating mode, yes.
okay,
This is full communicating, by the way.
yeah.
After your.
This will not apply to 24 volt. So, once you hit the gap, it's going to energize auxiliary heat. Now well, I'll explain that in a minute. Or in a little bit when we get to the control part of it, how it controls. So, no, so once you hit the gap, like I said, once you hit the gap, it's gonna bring on the auxiliary heat, that's where the delay comes in handy. Because you can actually set that delay off. And then what happens is, if the heat pump shrinks the gap, and gets it below the gap, then the auxiliary heat never comes on.
That's where we start turning that delay on and then increasing our delay on our auxiliary heat up to 30 minutes.
Right,
So now we have to hit that gap and we have to get the delay.
right.
I would imagine that air handler's saying, hey, look at my gas tank, look at my coil tank, look what I'm doing, I'm able to do something, I'm doing something.
Okay, so I'm telling you right now, they are trying to do something with intelligent auxiliary heat control. Aaron, if when, you can't see it when it's you can't see it when it's in presentation mode, but I've got some, slides in there that are hidden that are new, that I haven't been able to wrap, we haven't been able to wrap our heads around, plus we haven't gotten an explanation from China on it, on what they actually mean.
What it's actually saying.
But it looks to be from what I saw on the slides, that they are trying to do something with intelligent auxiliary heat control. Where it looks at the T2, well, it looks at the T2 temperature. And says, hey, my coil's producing enough heat. I don't need to turn on the auxiliary heat. Now that's what I've seen, that's what it looks like to me, but I haven't got full explanation. So as of right now, the slides are hidden because I don't want to show them to you. And I don't want to try to explain them if because I don't fully know that that's what's going to happen.
I appreciate that. I know a lot of our dealers are looking at this as, you know, we're used to installing heat pumps with strip heat that lose capacity starting about 35, 30 degrees.
30 degrees,
So
sure.
we get really sensitive about, do we want to be comfortable with auxiliary heat being engaged more readily? Or do we want to be efficient, where we're going to be pushing that heat pump? But being that we have a unit that is running down to 5 degrees at much higher capacities, I feel like the understanding and the applications that our electric heat operation is going to be a lot less relevant than it would be on.
The only time, yes, it will be a lot less relevant. The only time it will come into play is if somebody puts the setbacks on it. But like I said, but my policy has always been, especially with heat pumps, that you do not gain any efficiency or gain any energy savings by setting them back more than 3 degrees.
Well, and I know all of our dealers have those conversations with customers, and anytime we have that battle, it's like telling the little kid to shut the door on the way out, right?
Right.
It's a fight you're always gonna have.
Exactly. It's always a fight you're gonna have. You know, you tell people this, you're like, okay, well, then I had customers do it to me. And they're like, but I wanted this temperature in the house. Then I'm like, then deal with the bill and quit complaining about it.
Yeah.
You're the one that's causing it. You don't save any money by those big setbacks. People don't understand that. And you can't make them understand it either. Anyways, so now my policy, Deb,
Do you wanna take a 10, 15-minute break?
wow, time flies when you're
About
having fun.
9:30 now.
Yeah, let's go ahead and take, guys, let's go ahead and take a 2-minute break here.
10 minutes.
Hey, Ryan. You said there was an outlet.
Oh.
Water,
Yeah.
maybe somebody could grab one.
Yeah. They are
All right, you're good to go.
Okay, all right, does anybody have any questions on dip switch, what we've covered on dip switches so far? All right. Next set. SW2-4. Guys, this used to be a either or dip switch. So you could either lock out the compressor or you could lock out the auxiliary heat, but not both. We asked for individual control so we could lock out one or the other. We asked for individual control. So if we wanted to lock out the compressor at one point and lock out the auxiliary heat, we had the ability to do both. This is what they gave us. We wanted a separate dip switch and a separate rotary switch. So they combined it out of the box with SW2-4 and the rotary switch S3 set to 0. There are no lockouts. So the compressor will run at any temperature and the auxiliary heat will run at any temperature. If you set the S3 rotary switch to, let's just say A, which is 25 degrees Fahrenheit. If you set that to A, any temperature below 25 locks out the compressor, but not the auxiliary heat. Any temperature above 25 allows the compressor to run, but not the auxiliary heat. So it locks out the auxiliary heat, but not the compressor above that temperature, and locks out the compressor, but not the auxiliary heat below that temperature, which this makes no sense to us. Personally, I wish I could just switch it back. That's the way that operates. If you turn that switch on and set the S3 switch to a temperature, it will only lock out the compressor. SW3-3, that is the temperature differential for W2. Out of the box, it's set for 6 degrees. Now, that is not just to clarify, that is not 4 degrees from W1 and 6 degrees from W2, so the temperature does not have to drop 10 degrees. They run side by side. So, if you have W1 set at 4 degrees, and W2 set at 6 degrees, W1 will come on, will activate once the temperature is 4 degrees off set point, and W2 will energize once the temperature is 6 degrees off set point. That can be reduced by turning the switch on to 4 degrees. SW4 1, 2, and 3. SW4 does nothing. This is electric heat nominal CFM adjustment. So you can actually, now it comes out of the box, they come out of the box, set as high as they go. By setting these dip switches, and there's a table in here. By setting these dip switches, you can actually turn down your electric heat CFM.
So it'll be the maximum CFL that particular air handler can run for its maximum strip.
What happens when we energize auxiliary heat is the fan automatically goes to turbo mode.
Okay.
So this affects turbo mode and the electric auxiliary heat.
So if you have a 3-ton air handler
Uh-huh.
and it's able to do 15K, but you only have, let's say, you put it at 10.
Right.
Obviously, we're gonna want to adjust that.
You're gonna wanna adjust that because I'm gonna tell you, if you put that 10 kW in that 3-ton AHU, you're not gonna get much heat out of it.
And does it take, when it gets that aux, or the strict heat call,
Mm-hmm,
and it's in a Y2 heating call,
mm-hmm.
does it always run at whatever the highest airflow call was at that time? Perfect.
So is that true, like if my strip heat stayed on, so if I bring on 5 kW, let's say I got 15 in there, but only 5 comes on, I'm still gonna run at 100%?
Yep.
Okay,
So we're just adding to the heat, but we're not adding to the airflow because we're already at the maximum of what that airflow should be for
Right.
that system. Okay.
Right. I know other manufacturers do that, they increase it, but they don't increase it by as much as we do. Some of ours increase by a full ton of air when you energize the auxiliary heat. That's why if you're going to put auxiliary heat in these, make sure you size the auxiliary heat for the entire heating load. Do not size it for the difference.
I've seen where we'll find a balance point, and then we're adding to the BTU of the outdoor unit that adds that balance point. It's gonna bite you in the butt.
No, my problem with doing it that way, you can do it that way. Problem is, what happens when that heat pump goes down? And you have to use auxiliary, you have to use emergency heat.
You don't have enough.
You don't have enough.
When I think a lot of our local jurisdictions will see that.
Uh-huh.
On obviously permitted jobs, so look at that, but no.
Yeah. SW5, 3 and 4. We'll talk about number 3. Basically, if you're using an alarm relay output, you can set SW5-3 to either, it comes out of the box, set for if there's an L output or a fault. For 24 volt, the alarm relay will close anytime there's a fault detected. You can set that up to where it will only fault if there's an A2L fault. SW5-4 realistically is only for full 24 volt communication. What that does is, and the reason I say that is what that does, if you flip that switch on, what it will do is it will break the R circuit going to the thermostat. So if you have a 24 volt thermostat, but you still have S1, S2 communication between the outdoor, when that thing senses an A2L fault, it's still going to shut the outdoor off no matter which way you set this.
Which is the most important.
Right. This SW5-4 is for 24 volt full communication. That's where that pigtail comes in. Because that's what that pigtail does. It wires straight to the outdoor unit. Remember that pigtail I told you to ignore? Yep. That's what that pigtail does. When you plug that into the board, those are the outputs to the outdoor unit. So if you're in full 24 volt communication mode and the indoor air handler senses a A2L fault, it breaks the outdoor unit, shuts it down that way. Or you can do it this way if you're on full 24 volt communication, but that is only, the SW5-4 is only for full 24 volt communication. If you're still using S1, S2 to the outdoor unit, regardless if you're using a 24 volt thermostat up here, the S1, S2 communication will still shut this off. All right, so now let's talk about 24 volt thermostat and S1, S2. All right, see here all right, so you're gonna have 24 volt thermostat wired to your 24 volt thermostat or your 24 volt terminals on the air handler. S1, S2 to the outdoor. Gives you full communication between the indoor and the outdoor. If you do not have to set any dip switches, it's supposed to auto detect. If for some reason, like I said before, there are some thermostats out there that may or may not, it may not detect. If it doesn't detect it, flip dip switch SW1-1 on, and it will put the air handler in 24 volt mode. Not standalone mode, but 24 volt mode. Yeah. All right, so here's that indoor unit. This is pretty much the same thing. You have the by communication, it'll automatically recognize the 24 volt signals. The indoor and outdoor just needs S1, S2. Indoor unit thermostat control with 24 volt VA signal. And Even a retrofit, like we said before, even with a retrofit, you do not have to change the wire if you can't change wire. You can still use the existing wire.
But your recommendation is if there are extra wires, to clip them out of the way and
Clip 'em out of the way.
or wire
Do
them
not
together.
take them, do not take them like you would
Wrap 'em
typically
around,
do,
yeah.
and take those extra conductors and wrap them around the cable.
So you don't want them wrapped around the cable, you want them cut
I
out
want
of
them
the way.
clipped off back at the outer jacket.
But if there is a comm issue,
If
let's
there's a
cut
comm
them,
issue,
strip
if
them, wire nut them and ground them at one end.
Ground them at one end off, just like you would with the S1, the 2-wire communication cable with the stream. All right. So remember on full communication, T1 and TS are communicated to the indoor unit from the wired wall control. If we use 24-volt thermostat, what do we lose?
With the TS.
You have T1 available because what it's going to do now is it's going to use T1 here.
Or remove that TS from the,
We lose the set point from the thermostat.
because now it's just waiting for an input signal from the 24-volt controller.
Right, so we lose the T1 TS. Now, for algorithm control and ramping and compressor speed control, capacity control, everything in the algorithm, we have to be able to look at T1 minus TS. So what we do is when the 24-volt thermostat, when you plug this thing up, when you first plug this thing up and turn it on, the air handler, the AHU, uses a TS of 17 degrees C, which is, I think, somewhere around 64, 65 degrees F. So when the thermostat shuts off, when the thermostat satisfies, the 24-volt thermostat, because remember, we're not communicating TS anymore, or T1. When the 24-volt thermostat cycles off, the indoor air handler looks at the temperature condition of T1. So when it shuts off, if T1 is 71 degrees, it takes that T1 temperature reading and uses that for the TS on the next cycle. And it keeps doing that. Every time the thermostat shuts off, it looks at the temperature condition of T1 and uses that temperature for the TS on the next cycle. If you get this complaint, somebody said it ran for 3 or 4 days after, especially right after you started up. Somebody says it ran for 3 or 4 days perfectly, but now it won't come on. They've probably been messing with the thermostat. You probably got this engineer at home who says, that's not coming up fast enough. And he goes over and he turns the thermostat off. Well, if you start this up in a hot house and you don't let the temperature come down in the house, then his next thermostat temperature, his next temperature set point could be 80 degrees. Okay. So at 80 degrees, if the set point, if T1 is less than 80 degrees, say it's showing 75, it ain't gonna come on till the temperature rises above 75. Now, this is in cooling mode. In heating mode, it'd be exactly the opposite. So tell them not. So I'm going to tell you all, whether you're using wired wall control, whether you're using 24-volt thermostat with S1, S2 communication, this thing takes about 3 to 4 days to find its happy place, where it levels itself off and finds its correct operating conditions. So when you start these up, make sure your homeowners know they need to set it where they want it and leave it alone. Because it will not operate correctly if they keep playing with the thermostat when you're using 24-volt.
Have you had any issues with any particular brand of 24-volt thermostats on your system?
No, the only one we don't recommend is Nest because, and I'll tell you why we don't recommend Nest, is because Nest uses triacs instead of relays. our AHU, when you're using 24 volts, does not look for a 24 volt signal. So it does not look for the presence of 24 volts. It only looks for the presence of voltage. So what'll happen is, because Nest uses triacs, and it's not really a true common running thermostat because it's still considered to be a power robbing thermostat. So it imparts voltage back on those unused terminals. So if that control gets a call for Y and a call for W or W1, it goes, whoa, I got a call for heat and cool. I'm not going to do anything because I don't know what the hell to do. Okay. Nest is the one thermostat that I know of that we don't recommend, simply because we've had too much trouble at it.
We've seen that in some other systems too.
Yeah. Ecobee and Honeywell make some of the best thermostats out there. So that's what I would recommend.
We're recommending that.
We won't recommend that.
That's what we're recommending.
Yeah, Jessica will always recommend using
This right here.
Yeah.
the
This is what we recommend.
proper communicating control.
The thing you get is with the wired wall control, the one thing you really get is you get all the operational control. You get the full range of operation and modulation. The other thing is with the wired wall control, the unit operates at its peak efficiency.
Yeah, why use keys when you can with a fork with a key fob?
Do I?
It's like buying a new pickup that came with keys and a key fob. Why would you use the keys if you came with a key fob for a remote start and remote and wireless entry?
Exactly.
Yeah,
Which is why cars nowadays have got key fob. Most of the ones that have key fobs, the key fob's the key.
it's not sticking the key in the door. You don't need to.
Yeah. Okay, so other than that, everything else stays the same. All right, so here's your dip switch guide. Now, this is for 24 volt S1, S2 only. I'm not even gonna show you the other one. All right, switch 1, SW1-1, 2, 3, and 4 do not change. That basically is the same operation, no matter whether you're using. So, like I said, if your 24 volt thermostat if the AHU does not recognize your 24 volt thermostat, you can flip dip switch 1-1 on, and it will put it in 24 volt mode, and then it will work just fine. SW2-1 is for compressor running speed. Now, that demand this is only active if it's the demand with the heat pump plus electric heat, and it only affects the compressor in W1. Now, what this is, it comes out of the box set for a faster compressor. I don't know why you would ever change it to a slower compressor. So what that is, you can either change the speed, the compressor speed based on operating conditions when the heat pump and the first stage of auxiliary heat is operating. Basically, it can speed the compressor up, force it to run faster, or force it to run slower. Comes out of the box faster. So I don't think I would change that. For comfort reasons, I would leave it as faster. Because you got to remember, faster to this thing, it doesn't mean full speed. And I'll explain that to you. We'll get to that. SW2-4. Okay, SW2-4, doesn't matter which way you flip the dip switch or where you set the temperature, it works the same. It only locks out the compressor on 24 when you're using 24 volt thermostat. So my suggestion to you would be leave it alone. Because with the electric heat, first of all, with electric heat pumps, period, there was never any reason to turn the heat pump off, even at 10 below zero. Because even at 10 below zero, your coefficient of performance, now granted, was it blowing warm air? No. But you were still adding heat to the house, to the structure. And your coefficient of performance was still greater than 1. So there was never any reason, even with standard heat pumps, to turn the heat pump off at a certain temperature.
Most of those defrost boards had an ambient lockout anyway, because they
Right.
go back to shut themselves off.
So with this variable capacity equipment and our ability to heat and produce full capacity at such lower temperatures, there's no reason to lock the compressor out. Ever. That's the table. Table didn't change. All right, SW 3-1. All right, now, this is an important one. So when you come in and start this thing up, or if you've lost control of the house for whatever reason, after this thing's been running. SW 3-1 is the maximum continuous runtime allowed before the system automatically stages up capacity to satisfy the set point. It comes out of the box set for 90 minutes. Now what that means is, so it says this adds 1 to 5 degrees to the user set point in calculated control point to increase the capacity and satisfy the user set point. What that means is it's going to wait, if you've lost control of the house and you get this thing back up and running, or if it's on a brand new install, it is going to wait 90 minutes before it starts adding significant capacity to try to satisfy the set point. That can be reduced by turning the switch on to 30 minutes. So after 30 minutes, it will rank the compressor up or start adding significant capacity by adding 1 to 5 degrees to the user set point. That's the way it works.
We had a question on the SW 2-4 setting, the rotary switch. I believe it was a slide before this.
Yeah, where to do with it? Here it is. I did this all day yesterday because mine looks just like this. And I kept setting it down on top of this. I kept losing track of it.
Yeah. So SW 2-4.
All right. SW 2-4. When you're using a 24-volt thermostat, even if you're using S1, S2 communication, no matter which way you set this switch, whether it's on or off, will only lock out the compressor.
So really, we just leave that default position.
Leave that one alone.
Leave it alone.
I'm going to tell you to leave that one alone, even on full communication.
Seems like there's gonna be a lot of things that we're.
Because the thing is, like I said, it locks it. If it's off and you set it to a temperature, it locks out the compressor below that temperature, but not the auxiliary heat. And we don't want to lock the compressor out ever. So my suggestion is whether you're using full communication or whether you're using a 24-volt thermostat and S1, S2, leave SW 2-4 alone. Do not use it. And in the installation manual, I know I've seen it in one of them. When it talks about this scenario, they've actually combined these boxes and it's one statement. That was to eliminate confusion because they both say the same thing. It's worded differently, but they both say the same thing. All right, SW 3-1. We've already talked about that one. Let's go to number 2. So this is the cooling heating Y2 temperature differential adjustment. I don't know what the temperature differential is. It doesn't tell me. But if it comes out of the box on set for a faster speed. That basically helps. Because if we go to Y2, we want the compressor running faster speed. We don't want to run slower speed anywhere. SW 3-3 is compressor running demand. Again, SW 3-3 works the same as the other one. And that is the running demand with W2. So we're gonna leave it alone and let it run the compressor at the faster speed. SW 3-4 is okay, yeah, I know what that is. SW 3-4 is for turbo mode. Because remember, you lose that turbo fan when you go from wired wall control to a 24-volt thermostat. You only have, if you use the, so if you use the G signal is low speed, Y1 is medium, and Y2 is high. Okay, this comes out of the box set for high speed for the turbo function. Basically, turbo is disabled. If you flip this switch on, it puts the AHU in turbo mode, turbo fan mode, and you get the higher fan speed.
It's gonna add noise, gonna increase your static pressure.
Which is going to add noise, going to increase static pressure.
Yeah.
Of course, if your duct is designed correctly,
Yeah, big if.
but
Lot of ifs out there.
if the ductwork is designed correctly, you're only going to increase the noise this much. But if it's not incorrectly, you're going to increase it this much.
I can see that being something to help with a lot of,
And it could help.
long duct runs, needing
Long
more,
duct runs, yes.
needing more throw in some rooms because we're not
Exactly.
getting enough velocity.
Exactly. That's where that's useful. SW4, 1, 2, and 3. It's your electric heat nominal CFM adjustment. Again, that doesn't change. The table's the same. SW4, now this is what I was telling you, SW4-4 and SW4-2. Those come defaulted on. That has to do, I think that we asked them about that. We asked them to flip-flop it and come default off. And they said they had to reverse the logic and it took too much programming to redesign software for it. So those two come in the on, those come in the on position. SW4 or S4, which is 4 switches now instead of 2. S4 comes defaulted on, so all the switches are on. SW4-4 that's for your electric heat staging when you're using 24-volt thermostat.
So only a 24-volt thermostat.
Only a 24-volt thermostat.
Communicating, only 24-volt.
Right.
And what strip heat kits are 2-stage?
2-stage,
Yeah, so I mean, if we give it a W1,
10.
what K dubs are
10 kW plus.
8 and the 8 and the 10 are,
That's
the
right.
8 and the 10 are 2-stage.
So the 8 and the 10 are 2, and everything above this starts going to 3-stage?
15 and above is 3-stage.
So any of the questions that came through, should we jump out W1 and W2 for a 24-volt thermostat?
If you only have one stage of auxiliary heat available from the stack.
That's.
So if you're using a 3 and 2, a 3 heat, 2 cool thermostat, you're gonna have a Y1, a Y2, and 1 stage of auxiliary heat. Now, I'm gonna tell you, if you're gonna use a 24-volt thermostat, we recommend a 4 heat, 2 cool thermostat. That is so you can that is so you have the compressor stages plus staging of the auxiliary heat.
And this is only 24 volts, not
This is
using.
only 24 volts.
That's only if the customer would not give up their
Echo
Honeywell
me.
thermostat, and we
Right.
couldn't get them to use our recommended communicating thermostat.
Exactly. You're gonna have customers out there that love their Echo Me thermostat, or they love their Honeywell thermostat.
Which
You're gonna have
we'll
customers
find
out
We'll
okay?
find that.
That's what this is for.
Yeah.
So, you do not have to jump out W1 and W2 if you only have 1 stage of auxiliary heat available. Remember, it comes defaulted on. So, in the on position, which is default, W1 and W2 are energized anytime there's a W, anytime you send W1.
So it's gonna automatically.
It's gonna automatically bring on all the auxiliary heat.
It's if you wanna split it.
It's if you want to split it that you'll flip it off.
That makes sense.
Okay, so they do not have to jump out W1, W2. They can leave that switch in the on position, and as soon as they get to W1 call, they get all the auxiliary heat. Now, it doesn't bring it all on at once. There's about a 30-second delay between stages. SW4-2, which is only available for 24-volt mode, is your dehumidification terminal. Now, that dehumidification terminal requires an R input. Requires a 24-volt input to deactivate.
To deactivate.
Yes. So you could take, so what you could do is so it comes out of the box with it set off, where the dehumidification terminal is not functional. If you flip that switch off and it doesn't see 24 volts on it, it's gonna stay in dehumidification mode forever.
Which, in that case, are we just running less airflow? Are we just, instead of 400 CFM per ton, we're gonna run maybe 350?
Yeah, well, actually, we're not, actually, ours comes out of the box, we only run about 325, 350 CFM
Per ton.
per ton anyway.
Okay.
So it will actually slow it down even more.
Okay.
So now remember, this is only for 24 volt.
Yeah.
Okay, so you can do this one of two ways. You can take the DH terminal that comes off of that thermostat, run it through a reverse acting relay, and and close R.
And that's if they want dehumidification
Right,
with a 24-volt thermostat.
right,
Folks, please install a communicating thermostat.
yes, because communicating thermostat is going to take care of the humidity on its own.
That sounds like a lot of work.
The second way you can do that, this works the same way that the R to PK terminal worked on train. So you would run R through a humidistat and then back down to the DH terminal and use the humidistat to control your dehumidification.
All we're doing is running colder coil.
Right, all you're doing is running a colder coil so that you get more into the latent flow.
Yeah.
All right, this doesn't change. Remember, we're talking S1, S2 communication here, the R454B, the A2L sensor. S1, S2 communication, if that senses a fault, even if it's on 24-volt thermostat, we'll shut this off.
But we still have strip heat.
Because by the regulations, I don't believe you can turn on strip heat if there's if there's certain A2L faults.
They have to be UL listed, because I know that
Uh-huh.
there are products out there such as Train American Standard that are UL listed to allow strip heat to engage during an A2L.
And some of them do. As far as ours go, I want to say no. Ours shuts off the auxiliary heat, won't allow that to run either. Now that's if it's an A2L leak detection.
And the amount of refrigeration leakage from the equipment
We're gonna
to
go-
activate leaks.
We're gonna go through that.
Perfect.
Doesn't ours shut it down, and then once it's cleared, then it'll bring on the backup heat.
Right. It has to clear.
Yeah, it's got to run mitigation. There is a.
It's gotta run mitigation.
Mitigation.
Yeah, it has to run the mitigation first.
Yes, always.
Some of that has to do with the fact that, it's
It's an A2L product.
an A2L product.
Yes, plain simple.
But I think what's probably gonna happen is, I'm not gonna say it's gonna go away, but I think their eyes are gonna be opened here in the next couple of years, and some of these regulations are gonna drastically change.
Yeah. And if anybody hasn't taken any A2L classes, I would strongly recommend take some A2L classes to get a little better understanding of the requirements behind that.
Right. All right, so 24-volt mode, this is what displays in the AHU display when you're in 24-volt mode. Now these numbers tell you what the system is actually doing. So 0, in the display, if you got a 24-volt thermostat and S1, S2 communication, I'm gonna keep saying that because that's the way I want you to do it if you're using 24-volt. Using 24 volt and S1, S2 communication, if you display shows 0, 0, it means it's in standby or off. If it shows 0, 1, it means the fan's on. Right next to it in the table is the fan speed at that operation. So fan speed's low. 3 and 4, or I'm sorry, 2 and 3 are your Y1 and your Y2. Dehumidify 1 and 2, see where it says low? That's what it'll show you. That's for 4 and 5. 6 and 7 are your heat pump heating. Y1 and Y2. Most of the time, if you had, so heat pump, let's say, most of the time when you have the heat pump plus the auxiliary heat running, you're going to see 11. You'll see either a 10 or 11.
See, a Y, B, W.
Well, you're seeing the Y. Let's see, you're seeing the heat pump plus
W1, W2.
plus W1, W2. Or it could be heat pump plus W1. It all depends on how they wire it too. So remember, those two terminals are tethered together coming out of the box. So W1, W2 are tethered together. So if you put your W from your W1 from your thermostat and you land it on W2, it will change the designation here. It all depends on how they wire it. But anything 10 or 11 means you got the heat pump plus the auxiliary heat.
It looks like for auxiliary heat, it's looking for only the
Yes,
dash
it's looking for a call to that AUXE terminal.
So if somebody powered only W1 and 24 volt thermostat, let's say they had a basic Honeywell, and they only powered W1, it'll automatically, out of the box, power W1 and W2 without anything. So what's the difference between the emergency aux and
That's a separate terminal, and some of your thermostats out there have a separate E terminal on it.
But as far as that air handler, if it sees a W1 call, what is the difference between the way it's going to operate with a W1 call?
I'm not sure that there is a difference. I'm sure if you brought W1 or W2 in and energized it and they're tethered together, it's probably going to bring it on anyway.
So realistically, so we had some questions.
Because it's going to do that because not all thermostats have the E terminal.
Correct, some of them don't.
Some of them don't. Some of them, what they do is they just shut off the pump and they send out the W1 and W2 terminals.
So our recommendation is if you cannot use a communicating thermostat and you have to go 24 volt.
Right.
Wiring the E/aux on the air handler really isn't required.
Is not required. It all depends on your thermostat. Like I said, if you want to wire the E terminal, it's got the E terminal, go ahead, knock yourself out.
Okay.